Hello. Hello, Hack the North. Hello, world. How's everybody doing today? My name is Jeff Wentworth. I am a co-founder at CurveGrid based here in Tokyo, Japan, and I am going to present today Let's Mint an NFT. I'm super excited to be with you all. I can't see or hear you, but I feel your presence in Canada and around the globe and Japan, where I'm based. So it's super exciting. We got a lot to cover today in an hour, so let's get started. I'm going to share my screen. And the first thing I'm going to do, oops, that's not what I want. Yes, there we go. Okay. All right, perfect. So the first thing is you should have received a Slido link. We're going to be, if you want to ask questions, I think you can do so via Hopin or in Slido. We also have a couple of polls that we're going to be running today. The first one would just really help me understand who you all are, get to know you a little bit. So there are no wrong answers in this. First, basically just two questions. Love to understand a little bit more about your experience with blockchain, cryptocurrency, and NFTs. All of these are a little bit tongue-in-cheek, and as you go down the list, essentially speaking to more and more experience. My favorite one, I think, is this last one: deployment error, failed to estimate gas needed, which is a very common error message that we encounter when developing smart contracts and programming smart contracts. And then your level of programming experience as well. And this will just help me to understand maybe if I need to slow down a little bit or speed up a little bit. Yeah, wonderful. You can certainly vote as anonymous. That's no problem. And if you do have any questions, please throw them into the Q&A during the session. Type it in Slido or in Hopin, and I'll try to get to them either during the session or afterwards. Certainly don't be shy about that. So let's see. Without further ado, I'm just looking here. Where are we? Okay. Wonderful. Okay, I can see some of the answers coming in now. Let's collect some more answers on that. So I'll have a better sense of who you all are. Okay, so let's mint an NFT. I'm not going to put this into presentation mode so that I can sort of flip between tabs a lot more easily. I think the slides should be available afterwards as well. So again, my name is Jeff Wentworth, co-founder of a blockchain startup based in Tokyo, Japan, called CurveGrid. Feel free to drop me an email, or you can find me on Twitter if you like. The agenda for today, for the next hour, is introduction to blockchain, NFTs and why they matter. We're then going to talk about smart contracts, which are really just computer programs on the blockchain. Then we're going to do an NFT smart contract build along with the web-based Remix IDEs. The only things that you need are a computer and a web browser in order to follow along. And then you should be good to go. And all of these links should be in your hack pack as well. For those of you who want to check that. And then at the end, we're going to talk a little bit about what the future holds in terms of some of what you've probably heard around the climate impact of blockchain and how the things that we're doing to mitigate some of that. Prerequisites, basically basic programming knowledge. You certainly don't have to be an expert. A desktop web browser. And you don't need any prior knowledge of blockchain. We'll start from zero on that. So here we are, introduction to blockchain. We're going to keep this super simple and give you a 2-page overview of blockchain. You could think of a blockchain as basically a database that is distributed across the entire internet among thousands or tens of thousands of participants. And the real magic of it is that the participants don't have to know or trust one another when they're transacting. So if you're doing a transaction with someone and you're not standing right in front of them, generally you, let's say pre-blockchain, you need a trusted third party like your bank or their bank or multiple banks, if it's a banking transaction, to be able to reliably and securely transact with them. With blockchain, on the other hand, essentially all of the participants in the blockchain validate the transaction. And that's what we mean when we say distributed or decentralized. The blockchain, I think on a philosophical level is a combination of a number of existing technologies in a really clever way. And the first blockchain, the first public blockchain really was Bitcoin, which was started in 2009. And it's kind of confusing because the same word is used for the cryptocurrency, Bitcoin, as well as the blockchain technology, Bitcoin. So Bitcoin actually has two different meanings. So in this example, in this slide, we have two participants, Alice and Bob, and Alice is sending Bob 1 Bitcoin. And essentially it's -1 Bitcoin from Alice and +1 Bitcoin to Bob. And all of the other participants in the system validate that transaction. And that's what makes the transaction fast and relatively inexpensive in terms of transaction fees, because you have this decentralized validation. We'll talk a little bit more about cost in a minute. Page 2 of our 2-page overview of blockchain. So the next innovation, the next real fundamental innovation in blockchain was to realize that if we could do simple transactions like -1 +1, why couldn't we do a complex transaction? In fact, why couldn't we do an arbitrarily complex transaction? And another way of saying arbitrarily complex transaction is a computer program. So that's what smart contracts are. Sometimes you'll hear them referred to as tokens or NFTs. They're just computer programs that run on the blockchain. And the first public blockchain to really demonstrate this capability was Ethereum. So there's the Ethereum blockchain, there's the Ether cryptocurrency. So at least we have a little bit of separation of nomenclature now. And that's essentially what it is, right? Is we have computer programs running on the blockchain, validated by a decentralized group of participants. So in this case, it's a slightly more complex transaction where, for example, this could be a rental contract where Alice is paying Bob 1 Ether every month for 12 months, and payment is held unless Bob provides a signed invoice by the 12th of the month, right? So people say sometimes that blockchain is like a decentralized or distributed database. That is true, but it's also decentralized and distributed compute, right? Like almost like a decentralized AWS or Google Cloud or Microsoft Azure. So one last slide, kind of on intro to blockchain. Why is blockchain important? I think really 3 fundamental reasons. The first is fast transaction, low fees. And, as an example, right? I mean, the fees can vary depending on the blockchain you're thinking of, but it's, let's say, a flat fee of a few cents to send any amount of money globally in seconds. It can cost more than this. It can cost a few dollars. It can also cost fractions of a cent. But, the fact is that it's relatively inexpensive relative to amounts of money that you may want to send overseas. And it's fairly quick in terms of an absolute time scale. And you consider this, let's say, in terms of a credit card transaction. When you swipe your credit card or you tap to pay your credit card, the transaction doesn't complete there. That's simply the matching and validation of the transaction. The merchant, the store that you're in, doesn't get the money in their bank account until 1 to 4 weeks later. So the total lifetime of that credit card transaction is actually 1 to 4 weeks. Whereas with blockchain, we're actually doing that matching and then what's called settlement and clearing all within essentially anywhere from seconds to minutes. But actually the matching portion of it happens within a few hundred milliseconds. You will get immediate feedback as to whether this transaction is likely to succeed or not from the decentralized network. And primarily what we're trying to guard against here, prevent, is people spending money twice, or people, doing an operation on data, the same data twice that they're not supposed to be able to do. So it's the classic distributed database problem around essentially consistency, right? The second is complex transactions. So again, now it's essentially, some people say that smart contracts are kind of like programmable money. I mean, it's really programmable anything, or, at least into the short to medium term, programmable transactions, right? It doesn't just have to be in the financial services sector with stocks and bonds. It can be in gaming or the metaverse, right? AR and VR, or in microloans to people in communities that need them. I mean, it can really be anything like that. The final piece here is that the blockchain acts as a financial escrow service, and what that really means is that if you consider the sharing economy and organizations such as Uber, Airbnb, they have two functions really. One is a marketing function. The other is a financial escrow function. So the marketing function is I list my apartment that people want to couch surf on, or my rent. That's the marketing function. I'm going to match the renters and the rentees, or the buyers and the sellers, right? Or the drivers and the passengers, right? The other aspect of it is the financial escrow. I pay the service pays on to somebody else, and obviously they take a fee to cover the cost of both of those. And there's quite a substantial fee involved in the processing of the money, right? Because there's many participants involved, not just the consumer and the company, but also all of the credit card companies and banks and financial risk companies and everything in between. The point is that anything involving a transaction like this, the blockchain can eventually take on, I would say, more easily based on our current capabilities on the financial side of it, but eventually on the rating side, right? Is this a good passenger or a good renter? And you can follow the audit trail and the history of all of the past times that they've rented or stayed or ridden. And so I think it's important not just to understand what blockchain is, but why it's important and what are some of the potential future use cases for it. Okay, so moving along. Any questions so far? I do not see any questions. Again, you can ask in Slido or Hopin, or I think maybe even YouTube as well if you want, and I should see them. NFTs and why they matter. So NFT, for those of you who weren't aware coming into this session, stands for non-fungible token. Basically what that means is it's something that is uniquely identifiable. So think of something with a serial number, like a phone, as opposed to something that each one is the same as the other, like a box of bolts in a warehouse, or money, for example. This $10 bill is the same as these two $5 bills. They're essentially interchangeable in terms of their value. So I think it helps to work with an example. Excuse me while I take a sip of coffee. And for the purposes today, we're going to choose art because I think it's topical and it's also a pretty good thing to anchor ourselves in. So this is on this slide. We have this very existential question: what is art? I'm not going to attempt to answer that today, but I did want to draw your attention to some of the images on this slide. And of course, on the left there, we have the Mona Lisa, which most, if not all of you, probably recognize. The top, it's a First Nations painting. Upper right, I believe it's an Italian painting. At the lower right, we've got some digital media. And then at the bottom, we have a sculpture. And, everybody is going to have a different reaction to this art and feel differently about it, and ultimately value it differently. Now imagine an alien coming down to Earth from another planet, or somebody that grew up, not studying classical Western art, and looking at this. And if you were to ask them which one of these is most valuable, what would they say? Would they necessarily pick the Mona Lisa, which is probably the correct answer among these five in terms of what the market would be willing to pay for it? Not necessarily, right? And now we're starting to get into some of the aspects of art in terms of value and how that can relate to blockchain, which we'll talk about a little bit more in a minute. I also want to talk for a minute about what is this picture of the Mona Lisa? Obviously, it's a painting hanging in the Louvre Art Gallery in Paris. If I have a very high quality picture of it, or if I commission a extremely skilled oil painter who specializes in copying brushstroke for brushstroke this art, and they paint me an exact one, and I put it in a nice frame and I hang it on my wall, is that the Mona Lisa? It's not, of course. The original Mona Lisa has the provenance and the history behind it, sitting in the Louvre. But maybe I don't care. It makes me happy. I'm enjoying the art. It's on my wall, right? So when we start to talk about art and the blockchain and some of the possibilities and use cases, these are some of the considerations that I think are useful to think about. So the first is what we call provenance, or is another word for history, basically. Who created it? Who has owned it? How was it stored and displayed? And traditionally, in the art world, for higher value works of art, there's literally one or more massive binders of, here's the receipt and it was sold to this person on this date, and here's a write-up of it being displayed in this gallery, and here's the chain of trust from, it being handed from this shipping company to that shipping company, and here's photographs of the edges of it, right? And there's a very real cost associated with that, and it only minimizes the risk. It doesn't necessarily remove the risk in terms of, is this the real Mona Lisa or not? The second thing is the value, right? The cost of the materials versus its market value. So Mona Lisa is canvas and paint, right? I mean, that can't cost, in either today's dollars or a few hundred years ago when it was painted, it can't cost more than $50 of materials, and it's worth what? I think it's valued at north of $400 million now. Or consider something a little more mass market, like a baseball card, baseball trading card. It's just cardboard and ink, mass produced. But some baseball cards, a Mickey Mantle rookie card goes for $3 million at auction, right? So there's the value of something that we intrinsically believe in it because of its value to us, value to society, versus the actual cost of materials. The next one is ownership. So who has possession? And this is a little bit different from provenance, because it starts to get into issues of copyright and physical versus digital. So I use the example of the Mona Lisa and the expert painting copier, duplicator, because I think that we often start with NFTs with digital items. But it is possible to produce very, very high quality copies of physical items as well. But that aside, who has ownership of this item or items, and the copies of it. And then that ties into the last point, which is around rights. So, pictures or postcards of the Mona Lisa is one thing, but consider the music industry, right? So a recent song, any song that's been produced in the last 10 years almost certainly was recorded digitally. The masters are digital. The high quality audio copies that are being sent out or sold are, there's certainly MP3 formats or lossy quality formats, but you can buy the bits are the same as the original master. But who has the right to transfer, sell, lend, rent, commercialize that work, right? And right now, let's say in the music industry, that is all manual paper contracts, complex web of legal agreements, acrimony and frustration when things don't go correctly, and a lot of email spreadsheets, by the way. So what I want to start to think about in terms of the blockchain is, it's a tool, it's a technology that can make actually all of these things more efficient, not just for art, but for many other use cases. And that's essentially the problem that we're addressing with NFTs. So, again, no, I don't see any questions yet. If there are questions, please do throw them into the Slido or to the, I see one question. Do I need a wallet? You do not need a wallet today. Thank you very much, Skillsy Phase, for your question. You do not need a wallet. Wonderful. And yes, it is Leonardo da Vinci. Thank you. Thank you, Maurizio. Appreciate that. Okay, moving on. So we're going to do a really quick case study, and then we're going to dive into some of the blockchain-y stuff now. So really what kicked off the NFT, NFTs have been around for years, by the way, 4+ years. But really what kicked it off this year is an NFT that was sold at auction by a digital artist named Beeple, or Mike Winkelmann. And I think it was, let's say it was 11 or 13 years ago. Let's say 11 years ago, he started creating a piece of art every day and publicly posting it on social media, Twitter, Instagram. And he was doing that for 5,000 days. So he's not just some random person, right? He is a an artist, and he built up a following, built up interest in his art, shared his process with people through YouTube videos about how he creates his art. And then when he got to the end of 5,000 days, created a collage of these 5,000 images and went and sold it on Christie's. So here's the actual Christie's auction site of the Beeple collage. And if you zoom in, you can see that they're made up of all these individual images. And he put this up for auction and sold it for $69 million, which is not the most expensive art ever sold, but it's really expensive. It's up there. It's certainly up there. But it's interesting because, yes, it's a JPEG, but he's selling it as an NFT, right? So digital art has certainly been sold in the past, but the ownership was and the history and the provenance was all handled through more traditional means, like here's my log book of all the transfers that have been done, et cetera, et cetera. So what actually we have here on the Christie site is we have a token ID, which is a numerical identifier that identifies this NFT. We have Beeple's wallet address. You can think of this like his account address on the blockchain. We'll talk a little bit more about this later. And we also have the smart contract address. And again, the smart contract is the computer program on the blockchain. So this sold for $69 million. Christie's took, I think, a $7 million fee, which is for marketing, but also for the transfer and the provenance services, et cetera, which is, good on Christie's for jumping on this bandwagon early. But I think, as you'll see, that where some of the inefficiencies in the system can be helped by blockchain. So, okay, Beeple, art, JPEG, token ID, smart contract address. What I want to show you now is a website called Etherscan. And we talked before about the blockchain being a giant decentralized database that's distributed amongst tens of thousands of participants and is public across the internet. This is a website. Etherscan is one of several websites of a type that is a block explorer, blockchain explorer. And literally what we can do here is we can come in and we can see all of the blocks. So here's block 13 million and something. And inside this block, and I refreshed this page recently, so this is from 43 minutes ago, but I rest assured the blocks are up to date. This block includes 202 transactions in it. And here are all the transactions. Here's somebody at the top buying lemmings, adopting apes. These are actually NFT transactions. Here's a transfer, which could be an NFT or actually it's Ether. This allows us to essentially take a look at what's going on in the blockchain. Here's the first thing about this. If anybody can inspect what's going on in the blockchain, it's like radical transparency and radical trust, right? There's no more, backroom deals about like who's transferring the painting tonight, or, are they making a copy of this digital art or not? We can see literally everything on here. And indeed, in fact, this is the Beeple transfer, right? So this is what $69 million transfer of art looks like. Here we have from Beeple's wallet. So I'm going to read this out, 0xC6B0. We come back here, 0xC6B0. Smart contract address 2A46. Smart contract address 2A46. And he's transferring it from his wallet to the buyer. This cost him at the time $19.64. This was what it cost to transfer the artwork along with all of its provenance and history. And Christie's took a $7 million fee for it. That's a pretty good return on investment, I would say. The next thing that I wanted to, or profit margin, not return on investment, profit margin. Next thing I want to call it was this 40913. We come back here, we can see token ID 40913. So this is like the identifier that uniquely identifies this token. Here we are at Maker's Token V2. This is a smart contract on the blockchain. And again, it's a block explorer. So we can come in here and we can read from and write to this if we wanted to connect what's called our wallet. But we can see, for example, there's 70,000 NFTs here. And if we come down and take a look at the token URI and do query, whoops, I remove the comma. There we go. We get the URI or URL of the token. And if we were to paste this in and go to IPFS, we're actually going to get JSON, which represents the metadata of the token. And I'm going to pull out the, where are we here? This is the preview file. So I'm going to pull out this preview file here, this URL, and we're going to paste this in. And there we go. There's our JPEG. And if I posted in the real one, I would get a 320 megabyte JPEG file, but I didn't want to wait for it to load. So there we go. That is an NFT, start to finish. And it is stored on something called IPFS, or Interplanetary File System, which means that it also is decentralized. IPFS is a topic for another time, but it's kind of like BitTorrent plus blockchain together. So one of the things that makes this valuable, not only was it the first and represents this artist's kind of experience in history, but it also has this complete transparency. We know everything that's going on about this art, and I think it's a new way of not only tracking art but also things and items that is going to be really, really transformational going forward. All right, I don't see any additional questions. So I'm going to continue moving on, and I've showed you all of this. These are the backup slides. So we're going to go down and talk about smart contracts now, ahead of doing our smart contract build along. So let me see if I can go and check out the poll again at the beginning. Okay. What's your level of programming experience? Okay, so most of you are studying it in school. Okay, that's great. So you've got some and level of experience with blockchain. Okay, a little bit. Okay, perfect. So I think we're probably at the right spot. The smart contracts, computer programs on the blockchain. So one way that I like to look at a blockchain is as a decentralized ledger. So for any of you that have taken Accounting 101, you can kind of think of it like the blockchain, like a double entry bookkeeping ledger. If you haven't taken Accounting 101, like myself, then you can think of it like a spreadsheet. You can think of it as a spreadsheet where the data is continually being entered at the bottom and you can see everything above it. So that's what a ledger means. Double entry bookkeeping ledger means that we debit from one account and we credit to another. So we always know where, let's say, the money or the values are moving. Skillsy phase again with the question, will these slides be available? Yes, I will make sure they're available after the session, possibly in the YouTube description, but we'll make sure that we get them to you one way or another. And you have my contact info at the beginning as well, in case they get missed. Okay, so in this case, we have Alice sending 2,000 Ether to Bob, right? So minus 2,000 from Alice, plus 2,000 to Bob. You can think of these transactions as being an atomic entry on the ledger. That means that on the base technology level of blockchain, either the entire transaction happens or none of it happens. If any of you have ever dealt with bank transfers and either had money show up in your account that is not yours and asked about it and then had it magically disappear, or sent a bank transfer and the recipient never gets it because it goes somewhere else, that is essentially not possible with blockchain, right? Either the whole thing happens or it doesn't. And it's a fundamental construct of how the technology is put together. So these atomic transactions are grouped together into blocks, and blocks are appended to the ledger, and they're immutable. So the key point here with immutability, which means it cannot be changed, it's not that you can't change the blockchain or things on the blockchain. It just means that there is always a complete history of what has happened. So I can't go and, oops, sorry, yeah, we sent extra money to your bank account, tappity tap, tap, tap on the keyboard and just remove it, and the number disappears from my bank account. There will always be that essentially undo log, forever undo log of, or historical log of what has happened. Okay, and okay, there we go. So that will, sorry, I was just checking Q&A. And there's no new question. So that is it. That you can't sort of hide anything from people or fake it, right? The history will always be there. The next thing to think about to consider is that these account names, so we were using Alice and Bob and Carl and Diana, but these are actually very large numbers. Here they're represented in base 16 or hexadecimal that represent basically public-private key pairs, right? So I have a secret, very long secret that is stored in my computer or my mobile phone or multiple places, and that is my private key. And then there is a public key associated with that, and that's what this is essentially. It's my account address. So I can share this with the world, and people can interact with it and with me through it, and I can interact with the blockchain by signing transactions with my private key, right? And that's what we saw with Beeple, right? Here's Beeple's public address here, his public key, or the smart contracts address. Now, again, transactions can include computer code that will run on the blockchain. And in this case, we have computer code that is invoking a function called remit, which means send or send money with some parameters. And so that begs the question, right? Who or what is Bob? This account address, right? Well, Bob is actually a smart contract. Is a computer program on the blockchain, and this is one of the functions of Bob, right? Remit, right? Send some amount of value, right, to the from the person that sent the transaction to the recipient, right? And that's it. That's it. So essentially, these computer programs these smart contracts get uploaded to the blockchain and stored on the blockchain, and that's called deploying the smart contract. And then we can interact with them. Okay, so moving along. So to recap, computer programs on the blockchain, also called smart contracts. They can hold and dispense value, and the core value of the value of the blockchain is, in this case, Ether, or it could be Bitcoin, is used for economic for securing the protocol primarily, but then they also have it also has a secondary function of essentially being able to pay people. But yeah, it's a whole other topic that we're just going to leave for now. Smart contracts or computer programs on the blockchain are governed by their computer code, and they are immutable. So if you want to upgrade a smart contract, you basically would have to upload a new version of it, and you would see the old version and see the new version, and through different mechanisms, essentially tell people like interact with the new version. And there's automated ways of doing that as well. From a security, so this radical transparency, right? And we saw this over here where this is, again, a block explorer. I'm interacting with the smart contract, reading or writing to it. Anybody can inspect the smart contract and also interact with it. So this is kind of a crazy security model. Like everybody can see my code, therefore they can audit it, look for bugs, hopefully alert me of the bugs before it's exploited, and that's obviously a concern. But how do I prevent any random person from essentially transferring away my Beeple that I own? Well, the answer is I do that in the code, and I do it by linking actions to the addresses, right? So, for example, maybe only Alice is allowed to call remit, and I check the sender of the address here before I do any further actions. And then it costs gas to invoke. So, sorry, this is in yen. Just divide by 100 roughly for Canadian or US dollars. So it's about 5 cents to $1,000. Actually, the spectrum right now for public blockchains is not I would say almost certainly not higher than $1,000, but it can get much cheaper, like fractions of a penny or fractions of a yen. If you're talking about a public blockchain such as Polygon or Binance Smart Chain, Ethereum blockchain today, a simple transaction is more like a couple of dollars. And the last point is that a limit on gas prevents runaway contracts. So what we have is we have a smart contract which is a program that runs on the blockchain. And if we wanted, we can interact with it through a block explorer here. And we can interface with it through here. This is not super nice though. I mean, it's okay, but like, you know, it's just very generic. So typically what happens is a smart contract gets combined into a bigger blockchain application called a decentralized application, or a DApp. Basically, it's a website, a front end, sometimes a back end, running on top of a smart contract. So DApp, front end, back end, one or both, or either or, plus a smart contract running on a blockchain. Couple questions have come in. Is a smart contract just like a script? Basically, yeah, it's a computer program. Another question. Does Solana work similar to Ethereum? Solana is a different blockchain. It does. To actually do the processing of these transactions, similar to Java, right, with the JVM, the Java virtual machine, there is an Ethereum virtual machine, or EVM, with its own bytecode, right? So our smart contract gets compiled into bytecode, ones and zeros, and then stored on the blockchain. And Solana uses a different virtual machine and a different, almost like a different CPU model, if you will, versus Ethereum. So smart contracts are not one-to-one transferable. Does Ethereum have a gas limit? Another question from the audience. Yes, Ethereum does have a gas limit. That's partly what prevents runaway transactions and also from essentially overloading the network. So for example, in this block, the block gas limit was about 30 million gas. And that's going to dictate the number of transactions versus the size of each transaction that can fit into a block. Thank you for your questions. Okay, so moving along. So sample Dapps. So I want to just show you this very quickly, and then I think we're gonna move into the code along shortly afterwards. So a very famous Dapp is Uniswap. And this is essentially like, you could think of it kind of like a currency exchange, right? But here, for example, is the Uniswap dashboard. This is actually the functional dashboard, right? So I'd pick, you know, I want to swap like Ethereum into, I don't know, like DAI, for example, which is DAI, which is decentralized, what's called a stable coin. That one DAI equals basically $1. So you think of this as like your currency exchange at the airport. So this is their website. You know, this is a dashboard showing that people are currently have about $2.6 billion worth of equivalent value of money locked into the protocol. And every day, there's about $900 million being traded on this decentralized platform. And again, it's all via the smart contract. You could come to Uniswap on Etherscan and interact with the smart contract this way if you wanted to. You don't need this dashboard. So there's no centralized control over this, essentially, right? The developers spent years literally building it and then set it free on the blockchain. The other thing is I want to show you here is we can actually see the computer code that's being uploaded to the blockchain. So this is the smart contract code. We're going to look at this in a second. That is on the blockchain, that is managing in this particular chunk of Uniswap about $4 million worth of value, right? And I think we're going to see about, this is the LP token. So about $4 million worth of LP tokens. And this computer code is not stored like this on the blockchain as text. It's actually stored as this bytecode, the ones and zeros, right? In this case, shown in hexadecimal. But the contract developer, the smart contract programmer, has come to this website, Etherscan, and uploaded the original source code, pushed a button. Etherscan has compiled the source code to the bytecode and compared the two. Okay, so coming back to this, so sample Dapps, right? And then OpenSea. I want to show you OpenSea. So OpenSea is an NFT marketplace for any of those of you who have not seen this, right? So these are people selling their NFTs on OpenSea. And I'm going to leave this aside for a second because we have lots of other fun stuff to work on. And I do want to get to the hack along because we're coming down to sort of the 20-minute mark. Okay, so these links should all be in your hack pack. And you should be able to access them that way. NFTs, as we saw with Beeple, could be a JPEG or could be a video, could be any kind of art or collectible. We're going to take a NFT concept called, oops, where am I going here? Moving this over, called amulets. And an amulet is a kind of poem that that depends on language, code, and luck, right? So I'm not going to go through all of this, but essentially, the poem must satisfy 3 criteria. The first is that it's Unicode text, so its text has to be 64 bytes or less, so relatively short. And then the SHA-256 hash, in actual implementation, it's the Keswick 256 hash, of the text includes 4 or more 8s in a row. And the number of sequential 8s in the hash dictates how valuable or how rare it is, if you will. In addition, a formal requirement if you're going to create it on the blockchain, not for us today, but if you were to create this on the blockchain, is that you have to offset at least a metric ton of carbon to compensate for the mining work that was done. So here is a scratch pad, which is linked. The link is down here a little bit. Scratch pad. There we go. Scratch pad. I'm not sure if I linked that in the hack pack or not. So here's the SHA-256 hash, and you know, let's have at it. For example, where are we here? So hello world, for example. Okay, none of these have enough sequential 8s, more than 4 or greater. This is only 2. So this is the luck part. But if I type a single word, wince, hey, I came up with one with 4 8s. So that's a lucky amulet. I can also load some examples here, and you can see that I'm getting some different examples with 4 8s. So let's pick an example. If you can play it, as I play it now, you can take it. And this is an uncommon amulet. So we're going to work with this one. Okay, so where are we here? So this, I mean, you can read a little bit more about this, but basically, in addition to kind of the theory around this, for people that are minting these amulets on the blockchain, there's a Twitter account. They are on OpenSea as well, with these kind of nice images that are being created from them, and it's a little bit of fun. So I thought, why not poems, for example? So I'd like to direct you all now to Remix. So remix.ethereum.org, and this is an in-browser IDE or development environment. So there's a few different components to it. You should have the home here, and on the right, the first time you come to it, you may need to click the Solidity plugin to load this. But basically, that's going to bring up a few different tabs on the left: the File Explorer, the Solidity Compiler, and the Deploy and Run Transaction tab, or there are basically simulator. So we're going to be using a simulated blockchain today, which is why we don't need to offset any carbon, because it's just running in my browser, and it doesn't take any really doesn't take any extra computing cycles. We're just faking it, if you will. So what I want you to do then, what we're going to do then is we're going to create a new file, in the right place, in contracts, new file. We're going to call it amulet.sol. And for various reasons, so amulet.sol is opened here. For various reasons, what we are, hold on, my browser is frozen. I'm back. Am I back? All right, good. My browser was frozen for a second. For various reasons, basically we want a version of this smart contract that is being flattened into a single file. And so in your hack pack, I believe I have provided that here in the Amulet smart contract. And so you should be able to come into GitHub, Amulets Flat, and take a look at the Amulet Sol smart contract. And then if you click on the raw button, you can copy and paste the text into Remix. There we go. So there's my Amulet smart contract. You may be asking, why are we using an existing smart contract and why are we not building our own from scratch? A, it's way more efficient for a session like this. And B, I think that I think that taking a look at other people's code is a great way of learning. So what we're going to do is we're going to get a baseline by going end to end with this in Remix, deploying the smart contract, minting an NFT, and then we're going to go back and we're going to try and make some changes to it and see how we get along with that. Question from someone: is it just Ethereum that's in Solidity, or also Cardano? Cardano is another blockchain platform that recently launched support for smart contracts. Solidity is like, excuse me, C or Java. It's just it's a high-level programming language, and so you have the programming language, and then you need a tool called a compiler to turn that high-level language into the low-level bytecode. If you had a compiler from Solidity to Cardano or another blockchain, yes, then you could do Solidity with Cardano. I don't think that's the plan. There's a different programming language that they're planning on using, but eventually somebody may write a Solidity to Cardano compiler. I want to take a brief pause. I'm going to unleash a new poll. So I have just created a new poll here in this live polls. The poll is, what is your favorite number? And so what we're going to do eventually is we're going 7, strong 7. I see 1 7. Very good. We're going to what we're going to do is we're going to modify this from saying the number of 8 to a number of another number, a certain number of whatever other number you as the audience choose. So please lock in your votes now while I continue with the hacking session. We'll come back to this. Okay, so here we are in Remix. I have pasted in the source code from here. So I clicked raw, Control A, Control C, and then I went back into Remix and I created my amulet.sol file, pasted it in here. Now, so that's in my file explorer. Now I'm going to come down to my Solidity compiler and I'm going to click compile amulet.sol. So I'm compiling this. If it doesn't work, make sure that something in the 08 Solidity compiler family is selected. Then I'm going to come to my simulator here. And this has a few different, actually a lot of different options. The key thing is that it has a account up here preloaded with a whole lot of Ether. So we're just going to use this first one. The key thing here is, under contract, to pick the correct one, I need to pick amulet.sol, probably the second option. And then I want to deploy it to my blockchain. Now this is asking for some parameters, and I can expand this. Pre-mine mints and pre-mine reveals. I'm actually just going to put these as empty. So double square bracket or square bracket, square bracket. And if I was to do this in a single line, it would be square bracket, comma, square bracket, and then deploy. And I see my checkbox down here. And I can expand my amulet, and hey, we just deployed a smart contract. Incredible. The blue buttons here are the functions that I can call without the read functions, and the orange ones are the write functions. So here we go. Name, I clicked on name. I have amulets. Its symbol is amulets. Its contract, base contract URL is here. Wonderful. So let's try minting an amulet. Now, here we get to the first question, which is, what is this tuple? And a tuple is essentially a struct, which is like a combination of 2 or more values. So I'm going to come back to amulets.sol. And I know that I'm going a little bit fast. I am running a little bit low on time. I want to make sure I get through everything. But you can always come back to the recording later or ask me questions after the session as well. So this tuple. I happen to know is, well, let's do mint. Let's look for the mint function, right? So Control F, mint, open bracket. Here's the interface definition of it. Okay, so this is what I'm going to need to mint it. And it takes this parameter mint data, which is called the data variable. This is its type. So Control C, Control F, mint data. Here's its definition. So address owner, which is my public address, and then a token ID. I'm going to skip ahead a whole bunch, but basically token ID again is that Keswick 256 hash of the amulet. So it's like the encoded version of the amulet. So there's two steps, mint and then reveal. So first we're going to do mint. So where is my amulet scratchpad? If you can play it, as I play it now, you can take it. Control C on this. I'm going to come back and you'll see in the, here we go, Keswick 256 hash tool. I'm going to use this now. I'm going to paste this in here. And do I get the hash? I do. So I'm going to copy this. I'm going to copy this hash here. And I'm going to come back to Remix. And in Mint, I'm going to do two things. So open bracket, open square bracket, close square bracket, quote, comma, quote. I'm going to paste the, it needs to be prefixed with 0x. I'm going to paste the Keswick 256 hash into the second value. I'm going to copy my address as the first value. And now I'm going to click mint. So orange button, right method. I'm going to attempt to mint this token, this encoded, this hash poem to the smart contract. See what happens. I click the button. I get the green checkbox down here. And let's see, where is my balance of? So what I can do is I can see the balance of the number of poems that I currently own. I'm going to copy basically the inner part of this and paste it here. You can see I have my account address and my ID. I'm going to call that, and I have a balance of 1. So I've successfully minted an amulet. Now for the reveal. So amulets again are encoded. Now as this sort of mysterious amulet. Now I'm going to reveal it. So let me go here, F reveal, and I need reveal data. So just like I looked at mint data, I'm going to look for reveal data. And I need a title, an amulet, and the offset. So the amulet is the actual contract, so the actual poem itself. So coming back to my scratch pad, if you can play it, as I play it now, you can take it. This is our poem, right? And I am going to come back to Remix. I am going to do reveal. So it was title, which is just, my poem, and then the amulet poem itself, and then the offset URL, carbon offset here. And we're going to click reveal, and we get another checkbox, right? And what this gives me in the lower right here is essentially the ability to inspect these transactions. So I've expanded it now with the little triangle button. I can see that in the logs, right, which came out of the contract, I indeed have a title of my poem and then the amulet of the poem itself, along with the offset URL. We have just minted an NFT. Congratulations. All right. How are we doing on time? We have like 7 minutes left. So we're going to do this super fast. What's your favorite number? It's a four-way tie between 0, 2, 3, and 7 in the poll. All right, I'm just going to pick. I'm going to pick number 3. So number 3. So what we're going to do now is we're going to attempt to modify this smart contract to where are we here? Reveal. We're going to attempt to modify the smart contract to use 3s instead of 8s. So here we go. So amulet. So we're looking at reveal here, right? Amulet too long. What reveal is doing is it's calling this get score function. So we look at get score. Get score is actually computing the hash of the amulet. Whoops, sorry. Where are we here? Get score. There we go. It's computing the SHA-256 of the amulet, and then essentially like shifting its bytes over to count the number of 8s, right? What are the consecutive number of 8s? So we're going to change this to our favorite number, which is 3. And I'm going to do a sanity check on this to see what other 8s we have in the contract. Okay, just nothing else. I'm going to come back here and I'm going to collapse this contract. Oops. I'm going to collapse this amulet contract. This is our first one. I'm going to come back to my compiler and I'm going to compile it again. Compiling. There we go. Oh, I'm going to do one other thing. Sorry, because we don't have enough time. I don't have a ready. I don't know. Get score. Score. Okay. we're also going to make it super easy for us. So where are we here? Get score. We're going to only require a single 3 because why not? Mint and reveal 1. All right, there we go. So single 3 equals an amulet. So we'll come back here again. Whoops. Compile. And select amulet and nothing to pre-mint or pre-mine. Deploy. And that should have been deployed here. So here's our new one. Now, I am going to cheat a little bit because I'm going to just copy the values from here. And I am sure we have a 3 somewhere in this 256. Yeah, I mean, there's a bunch of single 3s, right? So we're kind of not proving anything with this except that we could make a modification, but that's okay. Okay, so here we go, mint, and did that succeed? Need to collapse this, scroll down. Yes, we minted. And then are we able to reveal, copy, and reveal? And there we go. And that worked again. Wonderful. So I want to take a step back for a second and talk about smart contract development in general, because I think that one of the challenges is like, where does one get started? And then where does an expert end up? And I think that one of the biggest issues is that that even though Ethereum's been around for 6 years or so now, the tools and the technologies are still moving very, very quickly, and many of them are still developing. Like we're not talking about like the Java or the C ecosystem where we've got decades of tooling behind us. There's still a very there's still a long way to go. And I think that, but I think that getting started with things like Remix, this in-browser IDE, and starting with even simpler smart contracts, or starting by modifying existing ones, is a very powerful way to start learning about this. And I hope that was this exercise was helpful for that today. In the remaining time, because I don't see any additional questions, audience Q&A. Is that so one of the issues, right, we want to talk about is reducing climate impact. And this is an article about the unreasonable ecological cost of crypto art. I think it's a very good article. I think that and this is from December last year, so even well before the current NFT boom. I think one of the key things is that we're essentially securing blockchains now by a mechanism called proof of work, which involves, proving that you've done a certain amount of work. So proving that you've done work, which means solving complex math problems, which means spending computer cycles on it, and those computer cycles translate into buying the hardware as well as electricity. And that's where the substantial amount of the cost comes from, is from the electricity. So of course we can use green energy, but the longer term solution is to switch from proof of work to something like proof of stake. And that's essentially where Ethereum is going. They have a goal. They had a goal from the very beginning in the original architecture paper, the white paper for Ethereum. We are moving to proof of stake eventually. Proof of work is the best we have right now. And the plan is either finally, right, it keeps getting pushed back, but either towards the end of this year or maybe next year, like they're going to flip the switch to that. There already is a live test networks that are using that in terms of, it's called ETH2, Ethereum 2.0. So I think that is going to help. And I have a couple slides here that I'm not going to share right now because we're out of time, that talk to that a little bit. In terms of improving usability, like we absolutely need to go from Etherscan and Remix to something that's a lot more composable, that's a lot more drag and drop. I mean, building an interface like, this for OpenSea or, this for Uniswap, like this is not easy. This is still really not easy. which is also exciting as engineers and designers and UI UX and product people and all aspects of the blockchain ecosystem. There is a ton of work to be done, and it's not just in cryptocurrency. It's not just in NFTs related to art. It's in trade finance, and it's in environmental and ecological and banking the unbanked, right? Providing access to identity and banking services for those that don't have easy access to it. So I think the long-term prospect of all of this, I would say, is that I think that blockchain is going to change the world, and I think that NFTs are going to be a really key part of that. We're up on time. Thank you very much. All of you. You know where to find me. You have my contact details are at the start, and actually I should pull that up again, and here they are again. You can find me on Twitter or email, and thank you all again. Really appreciate you joining me today. Take care.